If you've ever set up a high-end monitor, especially a projector with a long run, and seen, flickering pixels where the screen just goes black for a second, the problem usually isn't your expensive gear. It's almost always the copper trying to connect it.
Which I think brings us directly to the Kramer CLS-AOCDP UF-50.
Yeah, a name that just rolls right off the tongue, but we're doing a deep dive on this specific spec sheet because this is a 50-foot cable that is listing for around $332.
And that is a hefty price tag if you're thinking of it as just a cord.
Right.
But you really shouldn't. This is, it's technically a hybrid optical engine that's just disguised as a cable.
Okay, so the key acronym here must be AOC Active Optical Cable. I've got the data sheet open, and it's describing a mix of 4 optical fiber strands and 8 copper wires, all inside this one thin jacket.
And that mix is absolutely critical. The reason you can't just run a cheap 50-foot copper cable at these high speeds is just, well, it's basic physics. Exactly. Copper fights the signal. So when you try to push massive amounts of bandwidth through it, the signal attenuates. It just gets weaker and weaker until...
And that's the digital cliff people talk about, right?
Yeah.
It doesn't get fuzzy like an old analog TV. It just stops.
It just drops off completely. Precisely. Fiber optics, on the other hand, they sort of ignore that resistance. They're using light for the heavy lifting, not electricity. This Kramer unit uses what's called multi-mode fiber.
I see multi-mode a lot in networking gear. What does that actually mean for a video cable?
It's all about the thickness of the glass core. It's wide enough to let the light signals literally bounce around at different angles or modes. It allows for, massive throughput over these specific distances.
And when you say massive throughput, the spec sheet here lists a max data rate of 32.4 gigabits per second.
That's HBR3, high bitrate 3. That is the magic number you need to push uncompressed 8K resolution at 60 hertz.
So if you want your DisplayPort 1.4 to actually do its job without choking, you need this kind of pipe. Here's what always bugs me about active cables, though. Usually that word implies I need to find another power outlet, another brick to plug in, which is a total mess.
And that's the elegance of the engineering here. It is active. There are tiny lasers and converters in the connector heads, but they're so efficient, they draw less than half a watt.
So it just sips power directly from the DisplayPort itself.
It does. No external power supply. It makes the whole installation totally clean.
Speaking of installation, my worry with something this complex and with glass inside would be fragility. Like, I'd be terrified to snake this through a wall or bend it around a tight corner.
You would think so, but the build quality is there. The diameter is only 4.8 millimeters.
Super thin.
Very thin. And it's got a bending radius of 48 millimeters. Plus, that hybrid construction gives it a pulling strength of 25 kilograms.
So I can actually pull it through a conduit without, ripping the head clean off.
Within reason, yeah. And since you brought up putting it in walls, we have to talk about the jacket material. It's listed as LSHF.
Low smoke and halogen-free. Sounds like a health trend, but I'm guessing this is for building codes.
It's vital for safety. Standard PVC cables, if they catch fire, they release this toxic halogen gas. It's incredibly dangerous in enclosed spaces.
Oh.
So if you're installing this permanently in a ceiling or a business, the code often requires materials that won't, gas you out in an emergency.
So it really future-proofs the installation. You
Yeah.
get the safety rating and you get the bandwidth.
And you avoid the digital sparkle.
That's the technical term for those little annoying white dots, right?
It is. When copper cables are pushed to their limit, you get these little data errors that show up as sparkles on the screen. With active optical, the signal either arrives perfectly intact or not at all. It's pure binary.
It really feels like we're seeing a fundamental shift. As our resolution demands push into 8K and beyond, the era of simple copper wiring for anything but short distances is, well, it's ending.
It has to. The physics of copper, it just can't keep up with the data rates we demand now.
We're moving into a time where even our cables have to be active, light-based machines. And it really leaves you with a question to think about. You spend thousands on your display in your computer, but is your entire setup being bottlenecked by that $5 cable you just grabbed from a bin?